in the previous contest. You all can unmute and tell or write in chat box. So let us start our discussion. So we will be starting from the first question. So for the first question, how many of you all have solved the first question?
Yes, Bhaiya, it's all.
Okay. So you all can tell your approaches for this question.
Uh, First, I note the occurrence of one from starting and then from last, and the difference. If the difference is greater than target, then we will return no. Else, we will return yes.
Yes, it is correct approach. Anyone solved in any other approach?
Same.
Okay. So we will be discussing this solution only. So first, let us understand the problem statement. So the problem statement states that there are n number of doors in a row numbered from 1 to n. He needs to pass through all the doors and needs to exit means past one. So each door can be open or closed. If a door is open, then he passes it in 1 second. Means it takes 1 second to pass a door. Uh, if a door is closed, then he cannot pass through it. However, he has a special button which he can use at most one. This button makes all the closed door open for X number of seconds. So, in X number of seconds, maximum how many doors can I cross? Obviously, in X number of seconds, I can cross maximum X number of doors, correct? So, our task is to determine if we can pass through all the doors or not. So, we have been given n and the value of x and an array from 1 to n, and each element is denoting a state of the door. If the door is open, then 0, and if it is closed, then 1. If it is open, then 0, and if it is closed, then it is 1. So if I can cross all the doors by using the special power at, at most once, at most means that you can use it 0 times also, or one time, but you cannot use it more than one time. So how we will be approaching the solution in this way. Suppose A B C D E F. Suppose 0 1 0 0 1 0. See, so it is 0 means the door is open, so I can cross it within 1 second without any problem. But here 1 means the door is closed, so I cannot cross this door. So I have to use my superpower. So first we will be marking the index of the first occurrence of 1. From the last also we will be marking the occurrence of the last occurrence of 1. So within, if L and R are the indexes, then how many elements are present within L and R? What will be the formula for this? Anyone please unmute and tell. If L and R are the uh, yes, anyone was answering?
R minus L plus 1.
Yes, correct. It will be R minus L plus 1. See, like this 0, 1, 2, 3, 4, 5. So R is 4, L is 1. So 4 minus 1 plus 1, this is 1, is equals to 4. See, there are 4 elements only present in between L and R. So if I use my superpower, then all the doors will be open and then I can cross it. If this, so this number of elements, if it is greater than X, because my superpower will only last for X number of seconds. So if it is greater than X, then obviously I cannot cross all the doors. So this is obviously not possible. So if my number of elements is greater than X, I will be printing no. And if it is less than X, then I will be printing yes. So my pseudocode will look something like this. I will be taking input of A, and then all other things like NX, etc. So first I will be keeping a left pointer at -1. Uh, I will be going on from 0 up to n minus 1. If I find A of I is equals to 1, it means the door is closed. So I will simply put I into my L and then I will break out from my loop. So I've got the first occurrence of my element, and uh, over here only, and if I do another loop from backwards, so from n minus 1 till 0, and I will be keeping another pointer r is equals to -1. So if a of I is equals to 1, then I will put I into r and then I will break out from my loop. So till now my L will be containing the first occurrence, R will be containing the last occurrence of 1. So the number of elements is R minus L plus 1. If this is greater than X, then I will be printing no, else I will be printing yes. Is this logic clear to everyone? Okay. So I will be sharing the code with you guys. Is the screen visible? So I have taken first it was test case based problem. So in t equals to 1, I have taken input as t. After that, I am calling uh, t times my solve function. In solve function, I am taking input of n and x. Then I am taking the input of the array. After that, this is my left pointer. L is equals to -1. Uh, I am storing the first occurrence of L. Then R is will be my right pointer, which will be storing the last occurrence of 1. I am storing the last occurrence of 1 in this loop. After that, over here you can just do L equals to -1. You don't need to check for R equals to -1, because if L is -1, then for sure R will be -1 only. So any uh, if the L pointer is equals to -1, then I will be printing yes and then returning. Why I will be printing yes? Because what does -1 means? That I did not get any occurrence of 1, means all the doors are open. So if all the doors are open, then why I will be using my superpower? I can simply pass through it without any struggle. That is why if L is equals to -1, we will be printing yes and then returning. Else C is the number of elements. Number of elements is equals to R minus L plus 1. If this is greater than X, then I cannot cross all the doors. That is why I have printed no. Else I will be printing yes. Is this solution okay? So we will be going on to the next question. How many of you all had solved question number B? Okay, so you all can share your approach for this question.
Yeah, I took an array and I insert the maximum like n to its middle position and
Okay.
insert one to its last position and the remaining elements in ascending order in remaining places.
Yes. So the approach is correct. So we are given an array A of size m. We need to choose a index such that A of I, this is greater than A of I minus 1 and also greater than A of I plus 1. And then we remove AI from the array. So we need to define a score of a permutation P as the maximum number of times we can perform this operation P. So what does this mean? This means that I need to arrange. You all know what is the meaning of permutation in competitive programming? Can anyone please unmute and tell what does permutation mean?
Uh, Permutation means consisting, matlab, including all elements without repeating in an array.
Yes, correct. In competitive programming, a permutation of length n, it means that it will be containing all the elements from 1 to n without any repetition. Like a permutation of length 5, 2, 3, 1, 5, 4. It is containing all the elements from 1 to 5 without any repetition. but 1 to 2 is not a permutation because 2 is repeated, and also 1 3 4 is also not a permutation because 2 is not present in this. So this is the meaning of permutation. So in the question, we need to define a score such that this removal operation can be performed maximum number of times. So if let us first understand the solution from the example test case itself. So from both the test cases, could you observe a similar pattern? Can anyone tell me in both the test cases which have been explained, there is a similar pattern?
The n is present at the middle.
Uh, the highest element is present in the middle. Okay. Another observation which you can make. So another observation which we can make is that the array at, at the end will be containing only 1 and 2. Could you observe this? Means after performing the removal operation maximum number of times, the final array will be containing 1 and 2. Is it correct or not? This observation? Yes. So my operations will be like this. I will be removing the maximum element first, then the second largest element, then the third largest element, and this pattern I will continue till 3. After 3, I cannot make any removal because to make a removal, I need at least 3 elements. Correct? So I will reduce my array from n length up to 2. So every time the number of operation is equals to n minus 2. Yes or no? Like 1 3 2, n is equals to 3. So n minus 2 means 3 minus 2 1. So I can perform at maximum one removal operation. See, for the first test case we have performed one removal operation only. For the second test case, n is equals to 6, so n minus 2 is 4. So I can perform maximum 4 removal operation. So see, we have performed 4 removal operations only over here. Correct? So if I take this observation, I must arrange my array in such a way, arrange such that highest gets removed first, then my second largest element will be removed in my second operation, third largest will be removed in my third operation. So I have to arrange my permutation in this way. So one of the ways can be that suppose uh, a of 1 up to a of n is there. I am considering a of n as the largest and this as the smallest. Means it is going in decreasing order. So if I place my maximum element over here, or let us simply take n and these things only. So my maximum is n, correct? Second maximum is n minus 1, and so on up to 1. So if I place n and adjacent to n I place n minus 1 and 1, then see the condition is getting validated that the middle element is greater than both the adjacent element. Correct? After that, so first removal will be n. After that, I want that after removal of n, in the next operation, n minus 1 gets removed. So I will simply place n minus 2 to the left of n minus 1. Then I will place n minus 3 to the left of n minus 2. And I will go do this up to 2. So is this a valid permutation which will give the maximum number of operations? Or do you think that this solution is wrong? Anyone please unmute and tell. Yes. So this is a valid permutation because in my first operation I will be removing n. So after n was removed, then I will then I'm having n minus 2, n minus 1 and 1. So n minus 1 is the middle element which is greater than both the adjacent element. So in my next operation I will be removing n minus 1. In the third operation I will be removing n minus 2. Fourth operation I will be removing n minus 3. And uh, this process I will continue till only 1 and 2 is left in my array. Okay, so let us write the pseudocode for this problem. So suppose my answer permutation, this will be 0th index, 1th index, 2 up to n minus 1. So I am telling in n minus 1 there will be always 1. In 0 I will be placing 2, and after that I will just be placing all the elements in increasing order up to n minus 1. So see, at 0th index I am placing 2. So 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 2 is 4, and so on. This operation is continued till n minus 2. Correct. So my pseudocode will be something like I will declare a v of n which will be storing the answer. So v of n minus 1, there will be 1, and then simply I will be doing for I will be simply going from 0 to n minus 2, and I will be doing v of I is equals to I plus 2. And after all the operations, I will be just giving the output as v. Is the pseudocode clear to you guys? Okay. So let us share the implementation, how we will be implementing the pseudocode. So is my screen visible? So first, there are t number of test cases. We are calling the solve function t number of times. In solve function, I am taking input as n, which will be the number of elements in the permutation. After that, a will be storing the answer. The size of a is n. In n minus 1, I am initializing it with 1. After that, from 0 to less than n minus 1 means 0 to n minus 2. This loop will run from 0 to n minus 2, and a of I is equals to I plus 2. And then we are simply giving the answer output as out of a. Out of a means simply it prints the output. Over here, the function is defined. It will simply give you the output. So, is the code clear to you guys? Okay. So we will be going for the discussion of the third question. How many of you all have solved problem C? Anyone solved problem C? Okay. Anyone tried doing problem C? Yes. So what approach did you use? Means while trying.
Like, first of all, I counted the number of occurrence of the first element. So
Ye-
whatever may be the number of occurrence of the first element will be the maximum number of segments I can make.
Yes, this observation is correct.
Then I traverse, like, initially my segment was equal to one number of segments, and the maximum number of segments was number of occurrence, that is mainly four, like the occurrence of the first element. Then I decrease the occurrence of the first element. Then I traverse the array from second index to the last index. Then like, if the occurrence of the element plus number of segment comes less than the maximum, so the maximum number of segments get decreased, and like, uh, so I can again reinitialize the maximum as number of segments plus occurrence of that element. Then again I traveled, like, this was the logic.
So you are going for a n square approach.
No, that was only O of an approach. Like, I started a loop from index 2
So
to
this approach
index
will be
7.
giving the answer. Uh, did it give correct answer?
It only gave the pass the test case one. Rest it was
Oh,
in wrong in test case two.
yes. So if you should have used the n square approach also, then also see many things you have to keep in mind. Like this observation is correct that the number of times the first element is occurring, that can be the maximum number of segments. This observation is correct, but less than this also means it is problematic to calculate how many segments will be there. Like for the first test case, see many things we have to keep in mind. Like, okay, I can keep one in my first segment. After that, if I keep one in my first segment, then this entire thing will be my second segment. Correct? And here, if I keep one in my first segment, then this two one will be in my second segment. After that, 3 2 1 will be in my no, then the entire thing will be in my third segment. So see, every time first you will be checking one. After that, two you will be checking that whether it is occurring between two ones. Then these two you have to check in all the other segments which you will be forming, isn't it? So this approach is little bit complicated. Uh, we can solve it by thinking in this way. Suppose if I keep two containers, two sets, one as previous and one as current. So what my previous will be storing? Previous will be storing all elements in previous segment. And what my current will be storing? Current, it will be storing all elements in current segment. Correct? So if I start forming segments, suppose my segment one was there. Suppose it is containing ABC number of elements, and this ABC number of elements are present in previous. After that, I have started checking for segment 2. So for segment 2, suppose yes, so when will segment 2 become a valid segment? Can any one of you tell? When will segment 2 be a valid segment? Segment 2 will be a valid. Yes, you can tell.
ABC must be present in segment 2.
Yes,
Must be a
so at
subset.
least yes, ABC must be present in segment 2, and also any other element can also be present. So what I will be doing, I will be see my previous is containing ABC and my current is containing null. After that, I started the check for segment 2. Segment 2, whenever I am finding any element which is already present in previous, then I am erasing that element from previous. So like previous was containing ABC, I found that A is there in segment A. So I will be erasing A from previous. And then also while traversing, I will be inserting all the elements of the segment in current. So I have erased A from previous. Uh, Let us take this segment in a different way. So suppose A, X, B, Y, Z, C, and D, E, F, like this way. So I found that A was present already in previous, so I have removed A from my previous. I have inserted A in my current. After that, X was not present in previous. I will simply insert it into my current. After that, B was present in my previous, so I removed B from my previous, and then I have inserted B in my current. After that, Y it is not present in previous. I will simply insert it into my current. Z is not present in previous. I will simply insert it into my current. C is present in previous. I will remove it from previous. I will insert it into my current. Now see, previous has got empty. Whenever previous set is becoming empty, what does it signify? Can anyone please unmute and tell? If previous has become empty, what will it signify? See, when previous has become empty, it means that all the elements which were present in segment 1 are present in segment 2. All element in segment n minus 1, I minus 1 in segment I. Correct? So, if previous has become empty, that means segment 2 has become a valid segment. So, till this thing, we can tell that it is another valid segment. So, if this is a valid segment, I will be simply increasing my count by 1, and then I will be doing previous is equals to current. See, the purpose of my current was this only, that whenever previous has become empty, then I will simply be replacing previous with the current. And then I will do current dot clear. Means I will empty the current. Is this approach clear to you guys? That what we are trying to do. So the crux of the logic is that we will be keeping two sets, previous and current. Initially, both the sets will be empty. After that, whenever my previous I will be traversing the elements. If it is present in previous, then I will be erasing it from previous, and I will be at the same time inserting that element into my current set. And then if at any time previous becomes null, means previous becomes empty, then I will be increasing my count by 1. I will be replacing previous with current, and then I will be clearing my current set. If we do this, then we will get all the valid segments, means the maximum number of valid segments we can get, and then we will be simply giving the output as C. So let us see how we will be implementing this logic.
Can you explain it by a custom example? Like I will give you an example.
Yes. Uh,
Uh,
means yes. Tell.
a 1 to 1, 1 to 1.
1 to 1, 1 to 1.
Now,
Okay. So first, my previous is null and my current is also null. I will be going from 0 up to 5. So first one check will be there that if previous is not null, means not empty, then means not empty, not means if the count of a of I is present in previous or not, means like this way, count of a of I a of I from previous, and then I will be inserting a of I in current. If previous is empty, then C++ previous is equals to current and current dot clear. So for this example, let us use this pseudocode and try to find whether it is giving the correct answer or not. So C for 0, previous is null, current is null. For if count of a of I means a of 0, 1. Count of 1 is 0 only in previous. So this condition we are not checking. I'm inserting a of I in current. I have inserted 1 in current. After that, I am checking that is previous empty. See, initially previous is empty. This is true, and my count is 0 initially. See, for the first time we are getting this as true. So count plus plus. So count has become 1. Now, what I will be doing, I will be replacing previous with current. So now my previous has become 1 and current has become empty and my count has reached 1. Correct? So I have already got one segment over here. Now for second index, for 2, count of 2 in previous. See, 2 is not present in previous. So I will be doing nothing. Then I will be inserting 2 in my current. So previous is equals to 1. I have inserted 2 in my current, and then if previous is empty, see previous is not empty, so I will go for the next element. So for 2, so see, at 2 we are getting 1. So if count of a of I in previous, count of 1 in previous, it is greater than 0. So I will be erasing a of I from previous. So now my previous has become empty, and then I will insert 1 in my current, and my current has become equal to 2 comma 1. After that I am checking is previous empty. This is again giving true. Yes, previous is empty. So I will again be increasing my counter to 2, and then I will be doing previous is equals to current, and then current dot clear. So now my previous has become 2 comma 1, and my current has become empty. So I have found another segment which is valid. Till now everything is clear, or do you have any problem? Yes. So now we will go for the third index. Third, I am getting 1. So from previous, I will be deleting 1. So I have removed 1 from previous, and then I have inserted 1 into my current array. I have inserted 1 into my current array. After that 2, I have deleted 2 from previous, and then my previous has become empty. I have inserted 2 in my current array. After that is previous empty, which is giving true. So I will again increase my count from 2 to 3. Now I will be making previous is equals to 1 comma 2, and current is equals to empty. And now my count is 3. After that we will go, means I have found another valid segment. After that, the last index 1. For 1, I will be deleting 1 from previous. I will be inserting 1 into my current, and after that previous is not empty because previous is also already containing 2. So I am going out of my loop, and then I am giving simply output as C. And see, 3, this answer will be 3. There are 3 valid segments in this answer. What are the 3 valid segments? The valid segments are 1 2, then 1 1 2, and simply uh sorry, first valid segment is only 1.
1 2 1 1 2.
Yes, so first valid segment is only 1, then 2 1, then 1 2. 1 2 1, it is entirely in the last segment. Correct. So is the logic clear to you guys with this example? Okay. So we will be going. I will be sharing the implementation of this code with you. Is my screen visible? Okay. So I have taken input as t. I am calling the solve function t number of times. I have taken input as n. I am taking the n number of elements as input in a vector. I have set my counter to 0. I have got a set, kept a set as previous. Okay, so over here I have used set. Can we use unordered set instead of set? Anyone can tell me the difference between set and unordered set? What is the difference? Anyone can unmute and tell if you know. So basically, in a set, yes, tell.
Unordered set is means implemented in innerly we're using hash tables, but ordered just set is implemented using red black trees.
Yes, correct. So set is an example of a tree, means inside the implementation is through tree, and unordered set implementation is through a hashing algorithm. Means I will be giving a number, the number will pass through my hash algorithm, and whenever I will retrieving any element from a unordered set, the retrieval process will be in big O of one time. But in set, since it is implemented through tree, my retrieval will be in log n time. So you can understand that my retrieval process, erasing process, etc., it is taking less time complexity in unordered set instead of set. But here, if we use unordered set, then there are chances that our solution will be hacked. Can anyone tell me what is the problem with unordered set?
Collision happens.
Yes, correct. Like for the hashing algorithm, in C++, there is already a implementation of that hashing algorithm, how a number will be hashed, how a unique index will be formed, etc. Suppose if someone and in hashing there is a concept called collision. Like for two different number, if we are getting the same hash value, then what do we do? That at that particular hash value, a linked list is created, and after that retrieval is done from the linked list. And if retrieval is done from the linked list, then the retrieval is taking big O of n time. So see, in if many collision happens, then instead of retrieval in big O of one time, the retrieval is occurring in big O of n time. And if this big O of n we use it inside another for loop running from 1 to n, then the time complexity is becoming big O of n square, which will surely give TLE. So if the test cases are somehow made that the hashing algorithm is reverse engineered, and the numbers are put in such a way that collision will occur only, means it is must that collision will be occurring at every element. So my retrieval, instead of big O of 1, it will be in big O of n, and this will surely give TLE. A very good example of this collision is that if you solve the CSES problem of two numbers, means whether the sum of two number is equals to target or not. That question in CSES, if you solve using uh, unordered map, then you will be getting TLE, because the test cases are set in such a way that of n, it is a solution of big O of n square. That is why it is giving TLE. So most of the times in competitive programming, try to use set, map, these all things. It will be taking erase, retrieval, etc. In log n times, but that much time complexity, it will not cause any major problem. Avoid using unordered set or unordered map in competitive programming, because if someone reverse engineers the hashing algorithm, then your solution is sure to give TLE. Okay, that is why we have used set over here. So set of previous and then set of current. So initially both my previous and current is empty. So from 0 to n, I'm running my loop. I'm inserting that element into my current set. After that, if count of a of I, count is a inbuilt function in set, which counts the number of element, means how many times a of I is present in set. If a of I is present in set, then I will be erasing one of the occurrence of a of I. Means in set, obviously you will get only one occurrence only of a of I. So I will be erasing that occurrence. After that, if previous is empty, then I will be increasing my count by 1. I will be doing previous is equals to current, and then current dot clear. Means I'm preparing myself to search for the next segment. And then after I have exited from the loop, I will be giving output as C. Is this solution clear to you guys? Or you have problem in any of the state means lines? Okay. So we will be going for the fourth problem. How many of you guys had solved the fourth problem? Okay, so for fourth problem, what was your approach?
So in fourth problem, we can see that we can apply exactly means any one of the operation in means any one of the two operations in one at one time. So basically, what we are doing is we are subtracting each number with say we have calculated the first operation a times and second operation b times. So we are means subtracting a times the first operation and b times the second operation. That is a times I plus b times n minus I plus 1. So and that a and b is constant for all the elements because we are means carrying out the operation for all the elements. So what I have done is I've taken the first element and the last element, and means we'll say we are what we have means we have done the operation first operation a times and second operation b times. So the first element must be equal to a times 1 plus b n times b, and the last element must be equals to n times a plus 1 times b. So we are getting two equation and two variables. So we can calculate a and b separately by taking the first and last values of the array. Then we'll check the validity of a and b, whether if they are negative values then the answer will be no. If either a or b is a decimal number, I mean with decimal points floating value, then also the answer will be no. Else we'll iterate through the array, calculate the means required element for each index, then we'll check whether that required element is equal to the element in the array or not. If it doesn't match, then the answer will always be no. Else if all the number matches, then the answer will be yes.
Yes. So the approach is correct. So let us first start with the problem statement. So in the problem statement, we are given an array and we need to make all the elements 0. And for doing this 0, I have two operations. Operation 1 is that all the elements I will be decreasing them by I, and operation 2 is that all of the elements I will be decreasing by n minus I plus 1. By doing these two operations, I have to make my entire array 0. So how will we do it? So suppose if I say that I apply operation 1 C1 number of times, and I have applied operation 2 C2 number of times. Correct? So A of I, any arbitrary index, minus, if C1 number of times I am applying operation 1, then my elements are decreasing by C1 into I. Correct? And if C2 number of times I am applying operation 2, then my elements are decreasing by C2 into n minus I plus 1 number of times. And to explode the array, I need to make this as 0. Correct? So if this I am making it as 0, let us rearrange this equation. So A of I is equals to C1I plus C2 n minus I plus 1, which I can write it as C1 minus C2 into I plus C2 into n plus 1. And also my C1 and C2 will be integers, and C1 comma C2 will be greater than equals to 0. Correct? So I have got this equation. Let us modify this equation more. Instead of writing C1 minus C2, let us use capital A. Capital A into I plus this entire thing is a constant. C2 is a constant. N plus 1 is a constant. So can I write it as B? So I am getting A of I is equals to A into I plus B, where A and B are some constants. So can you all identify what equation is this? You all have read this equation in class 12.
Complex number, like
Not complex number. Try to think in sequence and series. You have seen this type of equation anywhere. A of I plus B. When you can represent every element as a constant into I plus B, then what do you call this series? Okay, so let us first
AI
break
is
this
linearly
equation.
dependent on AI.
Uh, could you please repeat?
AI is linearly dependent.
Linearly dependent. So when linear dependence is there, then what series is formed? Okay, so let me break this one, then you will be getting a clear idea. So let us start from I equals to 1 only. I is equals to 1, then we get A plus B. I is equals to 2, then we get 2A plus B. I is equals to 3, then we get 3A plus B. Now you can identify what series are we forming.
AP, arithmetic
Yes.
progression.
So this is a arithmetic progression. So one condition I got from here. So let me write all the condition in one place. One condition I got that my array must be a AP. Is this point clear? Because see, I have only done arbitrary things. I have never used A of 1 or anything. I'm doing all my operation in A of I only. So one of the conclusion I got that my array is a AP. Now it is certain that this is not the only condition, because some extra conditions will be there through the constants A and B. Correct? Now this extra constants will be giving me more number of conditions over here. So uh, over here, what does A is denoting? What does A denote over here?
Operation 1,
So in terms of AP, A is denoting common difference. Correct? See, because in every term I am adding one. Correct? So A is denoting common difference, and the common difference, if I made it certain that my array is a AP, then this will be equals to A2 minus A1. Correct? So I have got the value of A. So my value of A is A2 minus A1. Let us keep it at one side. After that, we will see that what other operations we can do on it. So I have got this one condition. Uh, Another thing I know, my common difference cannot be less than 0 in this case. It can be 0, means it can be a constant sequence, but it cannot be less than 0. So from here, uh, so my common difference is greater than 0, so A is greater than equals to 0. So A2 minus A1 is greater than equals to 0. So this thing is not doing me anything good. So let us see that from B can we form any equation or not. So what is my value of B? So over here you can see that I had replaced C1 minus C2 with A, and C2 into n plus 1 with B, correct? So the value of my B is C2 into n plus 1. So if my value of B is C2 into n plus 1, so I know C2 is greater than equals to 0. So if C2 is greater than equals to 0, then C2 into n plus 1 is greater than equals to 0. It means that B should be greater than equals to 0. One condition I got over here, that B must be greater than equals to 0. Another condition is that C2 belongs to integer. N plus 1 also belongs to integer. Multiplication of two integer is also integer. So B also must belong to integer, correct? So if I write it as C2 into B divided by n plus 1, so I can make it certain that B is a multiple of n plus 1, correct? How did we derive this condition? Is this clear to you guys? That how we are getting B is a multiple of n plus 1. But what is B? That is the issue. So I have to find B in terms of my elements of the array, correct? So how can I replace B in any terms of my array? Can anyone suggest? Means I want B as a function of elements of array. How can we? Because if only I have been given the elements of the array, if I means make B into some function of elements of array, then only I can say that after doing that calculation, then only I can check that whether the value that I'm getting, it is a multiple of n plus 1 or not. In this function, any idea? This is purely a mathematical question. Any suggestion that how can we find uh, B as a function of means elements of the array? See, what does B denote? B is denoting the constant value, correct? Of equation as I am just putting I is equals to 1 in this equation. So I will be getting it as A of 1 is equals to A plus B, correct? If A of 1 is equals to A plus B, and I already know the value of A is my common difference, which is equals to A2 minus A1. So I have found the value of B. B is equals to A1 minus B. So B is equals to A1 minus A2 minus A1. So B is equals to 2 into A1 minus A2. See, I have found B as a function of A1 comma A2, means as a function of some elements of the array, correct? So in this, I can easily apply the two checks that I have got over here, that B must be a multiple of n plus 1 and B must be greater than equals to 0, correct? So over here in the conditions, I have found some few more conditions. So over here in the condition, I have got more conditions. So my second condition is that B must be greater than equals to 0 and B is 2 into A1 minus A2. This is greater than equals to 0. And the third condition is that b must be a multiple of n plus 1. So 2 into a1 minus a2, it is a multiple of these two conditions. Clear to you guys how we have derived these two conditions, or is there any doubt? Okay, so it is clear. So my conditions on b are done, but still now I did not do anything on a. It is obvious that a will also give me some condition. So I saw that over here, if I do anything, then it is only telling that a2 must be it is not giving me any. C2 minus a1. uh where was the condition? Yes, c1 minus c2. Over here I have another equation of a. So let me see whether I can do anything from this equation or not. A is equals to c1 minus c2. So I know the value of a. A is a2 minus a1 because a is common difference. C1 minus c2. So c1 minus the value of c2 I can find from the equation of b, because b is equals to c2 into n plus 1. So c2 is equals to b divided by n plus 1. Correct? And I have already found the value of b. The value of b is 2 into a1 minus a2 divided by n plus 1. Correct? So over here, if I write c1 minus c2, the what is c2? C2 is 2 into a1 minus a2 divided by n plus 1. So I got this thing, and if I bring this term to the right hand side, so I am getting c1 is equals to a2 minus a1 plus 2 into a1 minus a2 divided by n plus 1. See, now from here we can do some checks. Wait, c2 is equals to b divided by n plus 1. Okay, so from here we can do some checks. uh, One condition was there on c1. Since c1 is the number of count, so I know that c1 must belong to integer and c1 must be greater than equals to 0, because count can never be negative. Correct? So c1 belongs to integer. Let us see that from here if I get any condition or not. I know a2 is an integer. I know a1 is an integer. Already I have proved that 2 into a1 minus a2 is a multiple of n plus 2. So this entire thing will also give me an integer. So any linear combination